Hello students, I'm J. Antoinette Sinula from Physical Science Department. Today I'm going to teach about light and its properties. First, let us see what is light. Light is the form of energy which causes sensation of vision in our eyes. Here, light is the energy which causes sensation. Next, we will see about the various properties of what are they? There are, say, 8 properties of light. One by one, we will see. First is light is a form of energy. And the second one is light always travels along straight line. This we will see further slides in detail. In diagrammatic form here, light travels along straight line. And light will never travel through a curvy linear lines. Always it travels along straight line. And what are the third property? Third is light doesn't need any medium for its propagation. What it means? Light it doesn't need any medium, or we can say in vacuum it can pass through. But if you take sound waves cannot travel in vacuum because there are no air molecules or medium in vacuum. Yes, therefore, sound cannot pass through in vacuum, but light can pass through vacuum because it doesn't need any medium to pass through. The next property is the speed of light. The speed is very high. Okay? The speed of light is, say, about 3 into 10 power 8 meter per second. Next property is light can travel in the form of waves. Okay? So, because of this property, light wave property, it has wavelength and it has frequency. For various colors, the frequency of the light and the wavelength of light differs. Say, suppose uh, red light, if you take, red light has more wavelength. Therefore, we are using red as a stop signal. But if you take blue light has very small wavelength. Okay. So wavelength, what is the meaning of wavelength? The length of one wave. Okay, the distance between this point and this point is the wavelength. If you take a red light, this wavelength is more, and for blue light, the wavelength is less to red light. So light is travel along waves. And next we came into reflection section. What is light? Light is the form of energy. What is the speed of light? The speed of light is 3 into 10 power 8 meter per second. Can light need any medium to travel? No, light does not need any medium to travel. Next property is refraction of light. What is refraction? So refraction, in order to know more about refraction, just see this is the incident light, this is one medium, and the light passes from one medium to another medium. Say, suppose this is air medium, this is water medium. So the light passes through the air medium and touches the water medium. Okay. At once it touches another medium, the light bends towards the normal. So this property of bending of light is called as refraction of light. Okay. And so refraction is bending of light rays when it passes from one medium to another medium. Okay. Here you are seeing light ray. This is incident ray, and this is refracted ray. The refracted ray is not in the direction of incident ray. It bends. Okay. So this property is said to be refraction. And why does refraction takes place when light travels from one medium to another? Because of the property of the velocity or speed of light. Okay? So refraction takes place due to the difference in the velocity of light in different media. Okay? See here, whenever the light travels in one media, it travels with one particular speed. If it enter into another medium, the speed of light changes. So because of the changing speed of light, this refraction takes place. Next one is laws of refraction. There are two laws of refraction. First law is the incident ray, refracted ray, and the normal all lie in the same plane. Here you can see this is the incident ray, this is the refracted ray, and this is the normal ray, normal line. That is perpendicular line. All the three are in the same plane. This is the first law. Incident ray, normal, and the refracted ray all in the same plane. Next, second law is Snell's law. So second law can also be called as Snell's law. What is Snell's law? Snell's law says that the ratio of the speed of light in vacuum, that is C, in vacuum, to the speed of light in the medium is equal to refractive index. Okay. The ratio of the speed of light in vacuum to the speed of light in, the ratio of the speed of light in air to the speed of light in medium is equal to refractive index. Okay. So refractive index gives us an idea of how fast or how slow the light travels. So if the refractive index value is more, then the speed of light in the medium is less. Okay. Because they are inversely proportional. Okay. So if the refractive index value is low, then the speed of light in medium is more. This is the significance of refractive index. Next is second law. The speed of light in a medium is low if the refractive index is high, and vice versa. Next, when light travels from denser medium to rarer medium. Okay. Say suppose what is denser medium? Denser medium is water, glass and all denser medium. What is rarer medium? Rarer medium is air. Okay. So whenever light travels from denser medium to rarer medium, the refracted ray is bending away from the normal. Okay, bending away from the normal. Here you can see the bending of light is away from the normal. This is normal line, and bending takes place away from the normal. And when light travels from rarer medium to air medium to denser medium, then the bending takes place towards the normal. And now we came to reflecting session. What is refraction? So refraction is nothing but the bending of light waves. What is first law of refraction? First law of refraction says that the incident ray, normal line, and the refracted ray all lie in the same plane. What is Snell's law? Snell's law is nothing but the second law of refraction. What is second law? Second law says that the ratio of the speed of light. Okay, here I can show it. Second law says that the ratio of nu, that is refractive index, is equal to C by V. What is C? C is nothing but the speed of light in air. V is nothing but speed of light in medium. So this ratio is equal to refractive index, a constant. Okay. Okay. So this is about the reflection part. And next one is dispersion of light. What is dispersion of light? Whenever white light touches the or passes through a glass prism, at once it is split into 7 colors. This is dispersion of light. So, what is scattering of light? When sunlight enters the Earth's atmosphere, atoms and molecules of different gases present in the atmosphere refract the light in all possible directions. This is called the scattering of light. Next slide, you can see, you can easily understand. Here, the sunlight is coming in the atmosphere. So, atmosphere is filled with the molecules and atoms. The instant light touches the molecules at once, the refraction takes place here, and the light is refracting in all possible directions. This refraction is said to be scattering of light. And what are the properties? What are the types of scattering? There are four types of scattering. First one is Rayleigh scattering. What is Rayleigh scattering? The amount of scattering of light inversely proportional to fourth power of its wavelength. This is Rayleigh scattering. What is Mie scattering? Scattering takes place when the diameter of the molecule is similar or larger than the wavelength of the incident light. This Mie scattering is also called as elastic scattering. The amount of scattering is independent of wavelength. And Tyndall scattering. What is Tyndall scattering? The best example is you take your room morning. See, if you open the window of your room, you can see sunlight comes into your room as rays. In those rays, you can easily see dust particles. So the light is scattered by the dust particle. That scattering is said to be Tyndall scattering. Next one is Raman scattering. Raman scattering is little bit complex. When a parallel beam of monochromatic light, okay, this is a parallel beam of monochromatic light. The monochromatic light means laser light. When laser light passes through gases or liquid or transparent solid, a part of the laser light are scattered. Those scattered light contains some additional frequencies other than that of incident frequencies. This effect is said to be Raman scattering or Raman effect. For this Raman effect only, Sir C.V. Raman got the Nobel Prize. There are 4 types of scattering: Rayleigh scattering, Mie scattering, Tyndall scattering, and Raman scattering. Okay. That's all about. Now we came into evaluation section. What do you mean by dispersion of light? Dispersion of light is nothing but whenever light, whenever light travels through a prism at once, it is split into 7 colors. Okay, rainbow colors. Okay, 7 colors. This property is said to be dispersion of light. How many types of scattering are there? There are 4 types of scattering. What is Raman scattering? This you can easily see. What is Raman scattering? Raman scattering is nothing but Raman scattering is the scattering takes place or the whenever laser light passes through the gas or liquid or solid, part of the light rays are scattered. Those scattered light contain some additional frequencies. That is said to be Raman scattering. And why sky appears blue in color? Because of the Rayleigh scattering. We have seen Rayleigh scattering. The amount of scattering is inversely proportional to lambda power 4. As the blue light has a less wavelength, the blue light scattered more. Because of this, sky appears blue in color. Who invents Raman scattering? Sir C.V. Raman invented Raman scattering. That's all about today's class. Thank you. Thank you, students.